All right, in this video we're going to be talking about solving exponential equations. Now, to solve exponential equations, basically you have to have the same base. Okay? You can only solve exponential equations if you have the same base here. Like in this case, we have the same base, 3 and 3. So let me write that the note over here. We can equate the exponents only if they have the same base. And this is what we're going to be doing in Algebra 1. When you go to Algebra 2, you're going to be learning about logarithms, that's a different thing, okay? So in this case, we don't have a problem. We have the same base. So now we can equate the exponents. So that means, let me get a different color here. That means that, hey, 3 is 3, same base. So we can solve the exponents. We can equate the exponents. So we can do x plus 1 equals to 5. And if we solve it by subtracting 1 to both sides of the equation, you should be getting the answer, which is x equals to 4. All right, so let's try this one over here. 6 is equal to 6 to the 2x minus 1. So pause the video, see if you are able to do it. All right, in this case, we are lucky enough that, hey, we have the same base. We gotta remember that this, if you don't have exponent, that's gonna be a 1 right there. So same base. We can equate the exponents and solve for that. So 1 equals to 2x minus 1. We solve the equation by adding 1 to both sides of the equation. Cancel, cancel. And we got 1 plus 1 is 2 equals to 2x. Divide both sides by 2, I should be getting the answer, which is x equals to 1. Questions? All right, so now, what if you don't have the same base? Well, if you don't have the same base, you can use logs and everything like that, but sometimes you can modify it, especially in this class, because we are not going to be learning about logs. We're going to be basically trying to solve the exponential equation by using the same base. So we can kind of like modify so we can have the same base. So what am I talking about over here? Well, in this one over here, 125, well, I can write down 125 as 5 to the third power. 5 times 5 times 5 is 125. So now we got the same base, and now we can solve it. And this one is really easy because it's already solved for you. X equals to 3. Let's try one more over here. One more example. Again, if you feel brave, you can pause the video and you can try yourself, but I'm gonna go over this one over here. Again, 9 and 3, they are not the same base, but 9 can be written as 3 squared. And we got 3 squared, okay, to the x plus 2. And that's equal to 3 to the 6th power. If you guys remember the rule of exponents, power to a power, you can multiply the exponents using distributive property. So we can rewrite this as 3. 2 times x is 2x. 2 times 2 is 4. 2x plus 4 equals to 3 to the 6th power. Hey, we got same base. So we can equate exponents and solve for x. So we got is 2x plus 4 equals to 6. we got a two-step equation. We subtracting 4 to both sides of the equation. 4 and negative 4 cancel out, and we got 2x equals to 6 minus 4 is 2. Divide both sides by 2, and you should be getting x equals to 1. Simple, right? Now let's try this one over here. It's a little tricky. Again, you feel brave, you can, pause the video and try to do it yourself. But this one over here, many of you say, Mr. Velosa, it's impossible to have the same base. This is 1. Well, you gotta remember the rules of exponents, okay? I can rewrite this as 2x to the plus 2, and 1, if you guys remember, every number raised to the 0 power is equal to 1. That was one of the rules that we learned, right? So 2 to the 0 power is 1. So now, guess what? Same base. And we can equate exponents. And so for x plus 2 equals to 0. Subtracting 2 from both sides of the equation gives you the answer, which is x equals to negative 2. Pretty simple, not that complicated. Again, I hope this was helpful for you guys. Please don't forget to do the assignments.